Hello everyone, I'm Noah Casey, and this is Daniel Guerrero. We're software developers for our team. On my left side is Joseph Pumphrey, he's our team lead. And on our far right we have Rachel Stevens, who is our Scrum Master. We created the STIG record manager for our clients over at Newick. Our project is primarily associated with the cybersecurity side of Newick. They want to prevent unauthorized users or adversaries from accessing their networks and their devices. Therefore, they harden all of their devices using STIGs. STIG stands for Security Technical Implementation Guideline. As its name suggests, STIG contains guidelines and protocols for users to follow in order to harden their systems. There's different types of STIGs for different devices. The ones that we're most familiar with is Windows 10 and Red Hat Linux, but also there's some for devices like cell phones, Blackberries for example. STIGs are currently evaluated using the STIG Viewer. The STIG Viewer is a STIG editing application which can also create checklist files out of these STIGs, or CKLs. Checklists are used by an individual user to evaluate their system security status. So every device at Newick would have its own individual checklist file. Here's a picture of the STIG Viewer in action. In the middle here we have a view of all the vulnerabilities associated with this current checklist file. On the right side we have a detailed view of a single selected vulnerability. And on the left side we have a graphical view of whether or not all of these vulnerabilities have actually been accounted for yet. So if I wanted to edit a vulnerability here, I would use these drop boxes at the top or the text boxes at the bottom here. But the trick is I would have to do it for every single vulnerability. And this can be really time consuming because when it comes to the Windows 10 STIG, there's actually up to 600 vulnerabilities. This process can be partially automated, however, using the SCAP tool. The SCAP tool takes in STIG benchmark files and scans the user's system, outputting a benchmark result file containing the different review of the vulnerabilities. But this doesn't actually work for a lot of the STIGs, so users are still constantly having to go back in and manually edit the vulnerabilities that I was talking about. So the main problem that our program is associated with is that STIGs are constantly being updated about once every 3 months. And when they're updated, users do have to go back through and edit and update their checklist files to be up to date. Now, as I showed you, the STIG Viewer can be a little bit clunky when it comes to handling this, so that's where our program comes in, the STIG Record Manager. The STIG Record Manager is a standalone desktop application built using Java, and it's intended to work alongside the STIG Viewer. It contains 5 core functionalities that we created for it. So let's jump into that and go over these functionalities in detail. The first function is straightforward. It's called merge. Merge takes a single checklist file and an updated version of that checklist file and merges them together, creating a third merged checklist file. And that helps with the users updating those vulnerabilities, like I said, because it just automatically copies it over for them already. Our next function is called comments. Comments takes the contents from that automatic scan I was talking about, and it appends the benchmark source, to the finding details section of the comments, or of the checklist file. So this helps the user to understand exactly what version of the benchmark is currently being used to validate their checklist files. So they don't want to have an out-of-date benchmark being used, they want to make sure that they're using the correct one. The next function is called match. Match takes the contents of the automatic scan, like I said, and it checks to make sure that those contents match the checklist file in question. And if it doesn't, it outputs a CSV file for the user to look through to know exactly what parts of their checklist needs to be updated, what needs to be looked at. You don't have to look at every single vulnerability anymore. The next function is called verify. Verify takes a list of checklist files and looks through them and makes sure that none of the fields are missing or not filled in, and it also outputs a CSV file for the user if it finds that something is not filled in. Our final function is called difference. Difference is a standalone function in the GUI, or sorry, not a standalone function. Difference is actually a viewing function in the GUI, and it takes two checklist files and hides their similarities, showing only the differences. This way, a user knows when you have a new checklist file of the older version of it, you know exactly what parts have been updated without even using the match function. On top of our core functionalities, we also created a detailed help page for the user to look through, so they don't actually have to know how to use our program going in. We actually have a guide for them to use. We created a customizable user setting menu for user personalization. And finally, we added the ability for users to edit certain parts of checklist files within our application. Our program was built using Java and JavaFX. We use IntelliJ and Eclipse for development. We use GitHub, Git, and SourceTree for version control. We use Trello to assign our user stories and keep track of our sprints. We use Slack to remotely communicate with each other. We use Google Drive to store our documentation and also work together on files remotely. And finally, we use Scene Builder to create our JavaFX file, which creates the GUI. And now I'll hand it over to Daniel for the demonstration.
Thank you, Noah. All right, so while we get the program open, before we even load anything up, there's something I want to bring your attention to. You may notice that there are three main panels here, one on the left and then two on the right that look very similar. And that's actually like that for a very good reason. So first, let's open up the files. So you can either open an individual checklist or a folder full of checklists. Here we're going to open up a folder, so you can just go File, Open, and now it'll load up. And now you'll see the first panel all the way on the left is full of file names. Those are the checklists you loaded up, and two of them actually have check marks next to them. And those are the two that you now see in those two panels. So this is a program designed to be used alongside the STIG viewer, so we did take a bit of inspiration from that design, but the intention was to make it easier to use. So let's go into our 5 utilities. The first utility is merge. And as explained before, what merge does is it takes two checklist files and it merges them together, because every 3 months the underlying STIG data is updated or changed and the checklists need to be updated to match that. But most of the time there are very minimal changes between them, maybe a few new vulnerabilities, a few vulnerabilities removed. So in this data set here, on the left you'll see a completed version of the checklist. So that's our old one. And on the right, you'll see a blank version. If you look on that very left column, the status says not reviewed, so it hasn't been filled in yet. And before, someone would have to go through and copy everything over by hand. That's not a fun process. It takes a while, especially since if you look at the one on the right, there's actually only a single difference. That very first vulnerability is a new one that isn't covered by the old one. So you'd be spending a lot of time copying everything over just because there's a single new entry. So when you run tools and merge, it takes the old checklist and your new blank template checklist and merges them together. So now all that old data is filled in as it was, because in all likelihood nothing has changed in the configuration on the system, so all that old data should still apply. And the one new vulnerability is right up top for you to deal with, and it just saves a lot of time, because now you can focus on whatever new stuff you need to do rather than spending time taking all the old data and re-inputting it. So our second utility, match, is used for those automatic scans. As said before, you can partially evaluate a system using an automatic scan if the underlying STIG data supports it. And if you're using an automatic scan, that scan should be correct. So what match does is it takes the output file from that scan and it takes your current checklist file and it compares them, because if something is mismatched between the two, there has to be a very good reason for it. So you can load up your checklist. Here we have a complete version, and we can load up the benchmark results file, and it will actually say that there are no discrepancies found. That's because this checklist file is generated directly off of those results files, so everything matches. But now if we take an alternate version of the checklist file, this one only has some vulnerabilities filled in, whereas other ones were intentionally left blank, and then we compare it to that same result, it'll say discrepancies found. So now it'll prompt you to save a file, and what that file does is it's a CSV file that you can open up in any spreadsheet editor you want, in this case Excel, and it shows you the benchmark file, the checklist file, and the status of the vulnerabilities between the two. So now you can see that that's the checklist file, so it's category 1 only, and then that's the benchmark file, which was the full version. So the individual vulnerabilities and then the status between the two. So benchmark had this as open, the checklist had it as not reviewed. And this just makes it nice and quick to see what the difference is, because if there's a difference, you need to know because something is probably wrong, and if it isn't, there has to be a good reason for it. So our third utility actually acts somewhat similar to match in that it is a validation tool, but rather than comparing an individual checklist to a benchmark file, it validates that a list of checklists are all filled out correctly. So there's specific metadata that associates a checklist with a specific system, such as the host name, the IP address. That has to be filled in. All vulnerabilities obviously have to be accounted for. So if you run tools verify, it'll actually go off of all the currently loaded checklist files and it will output a report. Now some of these checklist files we have loaded do have issues. So once we load up that discrepancy report, once again saved in CSV format, you'll see it outputs a nice clean report. So it'll say the checklist file in question, it will say what the discrepancy was, so finding details empty, host name not filled in, it can vary depending on where the issue was, and it'll show you the vulnerability in question. And that just makes it nice and easy to check everything before you send it off, because at the end of the day, this data has to be validated by an external auditing team, and they will look for little things like something isn't filled out, and if things aren't filled out, they send the entire file back to the team doing the review and say, redo this, you had this mistake, and it's just a long process, bureaucracy, that it's a long process, so making sure everything is properly filled out before sending it off is vital, and before you have to go through every single checklist, the STIG viewer does have a little visual tool that shows you the status of all the vulnerabilities, but say you're doing a system that is Windows 10 and then has 8 or 9 different programs on it, you would have to go through all 9 or 10 of those checklist files and verify it yourself to make sure everything's filled in as intended. And it is an error-prone process, so this makes it nice and quick. Our fourth utility is difference. So with these checklist files, when you're updating them, you probably want to see what's different between an old one and a new one, depending on what you're doing. Now, there are many reasons you might want to see the difference, so we actually have 2 different modes. So with this first data set, if we run tools diff, it'll actually highlight in line that certain things are different. Now, if the row is highlighted, that just means there is something different between the 2 vulnerabilities. So you can see those top ones, it turns out that their status is open, whereas the ones on the right are not reviewed. But this view gives a great quick view of what is different, but depending on what you're doing, you might want to see more specific info. For that, you can actually swap to a separate view, which is a standalone view, and now if we choose a different data set that fits this better, and load it up, it will pop up a brand new window for us, which shows us what is different in an inverted fashion. So if things are the same, they are blanked out. So those first 2 vulnerabilities, their status is actually the same, so their statuses are blanked out. But in the right version of the checklist, you'll see that there are some finding details filled in, there's some comments filled in, and those don't exist in the left version. So the left version is empty, the right version is there. If it's blanked out, that means it's either the same or not filled in. So depending on what you're trying to do, this view could be more helpful than the other view. It really comes down to what someone is trying to do at that time. So our 5th utility is comments, and when a checklist file is generated off of an automatic scan, the auditors want to know what version of the file was used for that scan, what version of the tool was used, and there's a very specific line of text that they want appended to every single vulnerability addressed by that scan, because as mentioned before, these scans don't cover everything, so you may have a file, you may have a full checklist with say 600 vulnerabilities in it, but only 400 of them are accounted for by the scan, and thus they want that information in the vulnerabilities affected by the scan. So you load up your checklist, you run tools, import comments, and it will now import that a specific comment based on the file you load up to the finding details of the vulnerabilities that are linked to it. So here you'll see at the bottom in the finding details box, it now says, determined by Red Hat Enterprise Linux 7 Security Technical Implementation Guide, Release 2.1, benchmark date 27th of July 2018. And that is information on that benchmark used to generate it. And that is pulled from the results file. and import it onto those finding details. You can have it overwrite existing finding details, or you can just have it appended to the end. That is up to the user and what they need. But all the auditors really want is to know that data is there, and putting it in by hand is a massive waste of time, so this just puts it into everything for you. So those are the 5 main utilities. Within the interface, you can actually do some basic editing of the vulnerabilities as well. For example, you can change the status by, say, double-clicking on the status. You can add an override. If you set an override, it will prompt you for a justification because that is a requirement of overriding a vulnerability. So we did try to add some basic editing tools, but this is designed to run alongside the STIG viewer rather than replace it. So because of that, we actually wrote some fairly extensive help documentation because not everyone who will be using this tool necessarily needs to know how to use all 5 main utilities. They may not need to do everything. They may just want to, say, import comments onto a checklist file, that's it. And rather than having to train users on the entire program, you can just give them the program and they can open the help menu and it'll show them how to use every utility in depth and in detail. So it makes it nice and easy to just give it to anyone who needs it and they can just pick it up and do what they need without having to worry about everything else. On top of that, there is a little shortcut within the main utility to open the STIG viewer directly if you need to do that. You can just set the path to it in the menu and it'll just work for you. And within the settings, you can also do other little things such as change the font size, change the font if you need to, make it a bit easier to see, and you can change from, say, light theme to dark theme if you desire a different view, and a few other little things here and there. So in terms of functionality, that is the main functionality of the program, and based on estimates from our client that were based on estimates from our client on a recent update that they had to do to various checklist files, the average Windows 10 computer could take upwards of 12 hours to update by hand, and with this tool, it severely cuts that time down because most of that 12 hours was just going through all 600 vulnerabilities, copying the finding details over, copying the status over, copying all of that over by hand, and this is a process that should have been automated a long time ago but wasn't. So we're stepping in to automate that to help save time, and we are very glad to hear that it is saving time already over in Newark. So with that out of the way, I'm going to pass it off to the floor to see if there are any questions.